All right, Keeper 9.2, testing a claim, test about a population proportion. All right, so just like last unit when we did confidence intervals, we have to check our conditions every time we actually want to run a test. And remember, we're running a test to test against some claim that was given to see whether or not there was some truth in the claim. But in order to do that, again, you have to check your conditions. Your conditions for your proportions, your population proportions are the same as before. Random, your samples must be collected randomly. Normal, we're checking NP, N1 minus P has to be both greater than or equal to 10. And independent, we want to make sure that the sample is taken with replacement or the 10% condition was satisfied, which that's little n less than or equal to 1/10 big N. All right, so when we're carrying out our test, when we're actually trying to see if there is some truth or whether or not we can find evidence against the null, we have to calculate something called a test statistic. So your test statistic basically tells you how far your value is, whatever you found in your sample, how far it is from what you would expect it to be. In other words, how far is it from the actual null hypothesis? Like when we did our shooting example, we claimed that we shot 80%, but you might have only shot 20%, or you might have only shot 10%, or something like that. Well, the test statistic is going to tell you how far away from that is in standardized units. In other words, we're standardizing the values. And so we're going to figure out how far it is from the actual p-value of the null hypothesis. Or, sorry, not p-value, but p-proportion of the null hypothesis. All right, so for this, we actually will. I know we talked about the 4-step process before, but we never really hardcore made you do a 4-step process. But for these tests, you will for sure do a 4-step process every single time. So the first thing you're always going to do is state your hypothesis, both the null and alternative. You're also going to state what significance level you're using. If it's alpha equals 0.05, alpha equals 0.01, you have to state that every time. And then you want to define the parameters. So like if you're talking about P, you're going to say where P is the proportion of blah, 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 whatever the context of the situation was. All right, so once you state all that stuff, then you're going to also say what test you're running. So for this keeper, we're doing a 1-sample Z test for proportions. We want to state that because by the end of this class, you're going to have several tests, and you want to make sure that you're stating it every single time. So you're going to state what test you want to use, and then you're going to check your conditions, your random, your normal, and your independent. After you do all that and your conditions are met, then you want to do your calculations. For each one of these tests, we're going to do 2 calculations. We're going to find our test statistic, which again tells us how far our sample value is from what we would expect it to be. And then we're going to find our p-value, which again is just the probability of getting that value if the null hypothesis was true. All right, once you get all that, you get your test statistic, you get your p-value. Remember, your p-value tells you whether or not you reject or you fail to reject the null. So we're going to conclude in terms of, remember, you're going to always state whether you reject or fail to reject in terms of the null, and then you're going to conclude your answer in terms of the alternative hypothesis. But again, your p-value is what's telling you whether or not you can reject or fail to reject. So if your p-value is small, you're going to reject, and if your p-value is large, then you're going to fail to reject. And you want to remember that all that we're doing, everything that we're actually calculating, we're assuming that our null hypothesis is true. So when we're using p, we're using the p of the null because we're assuming that it's true. We're basically, you're innocent until you're found guilty. So we're using that p-value, assuming that it's true. All right, so specifically for our 1-sample Z test or proportions, our test statistic is given by this formula. Z equals P hat minus P over P naught, or the square root of P naught, times 1 minus P naught over N. All right, so again, these are all a lot of different P's, but really this is just your P hat, which is from your sample. That's what you found in your sample. This is your population, what you're saying it is. That's your claim. And then over your standard deviation, again, this is your P. The P naught is of the null hypothesis. That's your claim. So this P this P, and this P. That's all of the null hypothesis, and this is of your sample. Alright, and remember, you can only do this if you test your conditions. You know, your 10% condition and your normal condition, and then your random condition. They have to be satisfied in order to run this test. Alright, so last thing, we want to make sure we understand that there is a correlation, there is a connection between confidence intervals and these tests. So if we're running a two-sided test, let's say at an alpha equals 0.05, that's the same thing. You're going to get the same information, or you're going to come up with the same conclusions if you had conducted or if you had calculated a 95% confidence interval. So again, the confidence interval, whatever your percentage of your confidence interval, that will always correlate to your two-sided test at the specified alpha level. Alright, so if, for instance, you fail to reject the null hypothesis, so you're going with it, you don't have enough evidence against it, you're failing to reject it, well then if you had calculated a 95% confidence interval, that number, whatever P naught that you found for your null, that whatever P naught they claimed, that number should also be inside of your confidence interval. So let's say our P naught was the proportion of shooting basketballs was 80%. Well, if we found to fail to reject it, well then that 0.8 should also be in my confidence interval if I calculated a confidence interval. And similarly, if I rejected H naught, well then I should not see P naught in my confidence interval. So the number should not be in my confidence interval because I'm rejecting it. It's not in a plausible value. It's not in a plausible range of values. So it's not going to be in my confidence interval. All right, that's it.